Okay, year 11 gentlemen, welcome back. And today we're gonna keep going with 2D, characteristic of the distributions and dot plots and stem plots. All right, so we actually able to separate them to two different parts. And the first one, we're gonna try to learn some key characteristics about the data distributions. And the second part, we're gonna try to do constructing the dot points and the stamp plot and the numerical data. And first thing first, the new key ideas about the characteristic of distributions, which is called the summary, symmetry, symmetry. My mistake. So the symmetry means the distribution is said to be the symmetric, and if the form is the mirror image for itself and fall into the middle along the vertical axis. And as we know how to draw the historical histogram below to the exactly symmetric, and which is histogram B shows the distribution approximately symmetric. So exactly symmetry look that if I draw the middle line in the middles, and we can say this one and this one are pretty symmetry. And this one approximately, all right, normally we will get the histogram B most likely. If you got a histogram A, that's very, very lucky one. And but histogram B is most likely one. Okay. Now the positive and negative screw, and then the positively screwed, and which is short tail and lefty and long tails point to the right, and the negatively the screwed will be right and long and tail the points to the left. So we can say positive is from 5 to 15, which is you going up and going here. That's around like the positively screwed, and negatively will be looks like you going to the left, which is you from here going here. That's actually is a negatively. And you will say, and the during the lectures or lessons, you will see the lots of histograms, and we can practice on. And central, so so centuries about the two distributions are center of the values of data with one distribution are generally larger than values of the data in other distributions. So what does that mean? Actually, for example, if I have a histogram that show the same scales, E and F, the identical one, we can say the shapes of weights and histogram E is moved horizontally from the 3 to 11 to the 8 to 16. So we can say they're actually moving, shape the whole graph to the right hand side and dedicating this distribution differ in the locations. So that means comparing the center. Okay, comparing the spread. So spread them, we can say histogram. We can say the group G are different with the spread. So this one together. But this one we can say those one are separated. So we can say separately out about those two items. And the dot plot, which is we can use data points and mark the dot, which is the several data points and same values, and then the point of stacked it on top of each other. Yeah, let's have a look. Let's start with some examples with the dot plot. So the numbers of works and 10 students in the part-time job filling this. So construct a dot plot of this data. Okay, 10 in total. So I'm gonna draw the hour works, which is the plan first. So first thing first, draw the horizontal line. The plan is called hours worked. 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 Perfect. And then let's try with. Let's try with. Start is 4 maybe because I saw the minimum point is 4 and the maximum is 9. So we can do is 4, 5, 6, 7, 8, and 9. So I move these hours worked a little bit here. Perfect. And I move the 6 to here. Alright, perfect. And then let's try how many 6 we have. 1, 2, 3, and 4. Perfect. We have 4. So we do 4 dot points. 1, 2, 3, and 4. And how many 5 we have? There's only 2. So we do 5 dot points. 1, 2. And 4 is only 1. So 1. And 7 only have 1 is 1. And then 8 is 1. And 9 is 1. Yeah, we can say that's the dot plot we can use. Hopefully that makes sense actually. You can say the most likely the 6 hours of the work, which is the common one. Yeah, now you can try this one by yourself. So that's why I'm gonna explain to you guys what is the dot plot is. Keep continue in next videos. We're gonna try to do the stem plots, which is the most important one. Okay, see you later.